Okay, instructions on sample spaces and simple probabilities. So, what I recommend is for the week before and after spring break, kind of introduce these topics and having students give feedback, asking them question first, having them make predictions is probably a good technique to do this rather than just directly stating and then have them take a note. But with the 70-minute class, and originally I said 50 minutes, I think maybe a half hour could be done on this. And since we're gearing up for the exams, all of those really basic skills that we cover at the beginning of the year, talk about properties a little bit, fractions, decimals, percents, discounts, taxes, converting things, those types of things. Okay, a sample space just tells us what are the options of what we're talking about. So you have a basket that contains, and I don't draw well, so I just wrote the words apple, apple, peach, peach, peach. But when you're doing the sample space, so we've got apple 1, apple 2, and then each peach. So that's just an example of a sample space. And then you put it in solution set notation. And that's just a curve to a point to a curve. And it looks like, a really bad cartoon of somebody's face. All right. Now you're gonna create a sample space, but we want to know the possible app. So this is a good one to talk to kids about baseball, right? When you go up to bat, there's only 3 possibilities other than, a natural disaster or injury, I guess. But if you go to bat normally and get the kids to give you the list, you're either going to get out, you're going to make a base hit, or you're going to make a home run. There are 3 options in that sample space. So when they're wanting the number of possible outcomes, this is what they're talking about. When they want to build a sample space, that would be the sample space. Okay, so now it gets a little bit more complex because now it's going to happen twice and you're going to have to build a sample space using set notation. Set notation means the solution set. And then, so let's do this. We've already determined. So the first time, you're either going to get an out, you're going to get a base hit, or I don't want to do it that way. So the first time we're going to do it based on your first at bat. There we go. First at bat, if you get out, all right, that's your first at bat. So this is now having received an out. When you go up to bat the second time, well, you have those 3 options again. You have an out, you could get on base, or you could get a home run. And so this is what goes in the sample space. So if you get an out the first time, right? If you get an out the first time, then the second time you get at bat, you might get out, you might get a base hit, you might get a home run. Now, what happens if the first time you were at bat, you got a base hit? Well, that's a base hit. But then the second time, you could get an out, you could get a base hit, or you could get a home run. All right. Now, what happens if the first time you're a bat, you got a home run? And when you go up the second time, you could get an out, a base hit. It's still the exact same options. So that's how you'd fill out a sample space, but visually, it makes it a little bit easier to do that. And when I was not doing it visually, I started to mess that up. So it's very easy to mess that up. All right. So this is going to be, so here's a good visual one. When a button is pressed, a computer program, so here you have a button on a computer, and my guess is this is just an icon button, not an actual button, right? You press a button in your computer software, and the numbers, odd numbers, so when you press this, you're going to get a number that falls less than 9 but greater than 1. So what I would recommend is have the kids actually put on the number line and then call this number line the odd numbers number line between 0 and 1. So we've got 3, 5, and 7, and that would be the sample space. Okay. So independent means the first event has no impact on the second event. So if you flip a coin, right? You flip a coin, you're either going to get heads or tails. If you flip a coin the second time, you'll either get heads, but these two are not related. Just because you get a heads here doesn't mean that you get, it has no impact on that. So this would be independent. Okay, this is now finding the probability. So the probability is the total events versus the event you're looking for, maybe desired event. Okay, a bag contains 7 red marbles and 4 blue marbles. Well, that's a total of 11. You randomly pick a marble and then return it to the bag. So you pick a marble, you return it to the bag. Both the first and the second, well, how many red are there? There are 7 red. So you have a 7 of the total 11. That's your probability, 7/11. And if you were to divide that using the calculator, and probability is always between 0 and 1. All right. Well, if you take that red marble and you return it, you're still going to have, and because you returned it, this is independent. Now, there's some people that argue, well, technically, because if you touch the marble and now it might have a film on it or might be dirty or something, and that could impact, like you might be able to determine that, you might be able to tell when you're drawing again which marble, but no, we're talking philosophically. If you return the marble, they have the exact same number again, there's still going to be 7 out of the total marbles. So that will be your probability the second time. Now, because we're finding the probability of 2 events, this is important. When you're finding 2 events, it's the probability of the first times the probability of the second. So if we want to know the probability of both the first and the second marble being red, it's 49 out of 121. Well, think about this. 50 over 100 is a 50% chance. So this is a little bit less than 50%, which makes sense because 7 out of 11, well, that's not true. 7 is more than 50%, but when you do the multiplier, because it's two events. All right, let's keep going. It's a really bad drawing. So your sock drawer has 2 white socks, 2 brown socks, 2 black socks, but you're getting up in the middle of the night and you don't want to bother whether it's a brother or sister, or if you're married, your spouse, you don't want to wake them up. So you have to randomly pick 2 pair of socks, and I don't know why they're not matched, but they're just loose in the drawer, which sounds actually not like a bad idea to me because it's kind of a pain folding socks. So determine whether this scenario involves independent or dependent. So when you pull out one of the socks, you're keeping it. So it started off being a total of 6 socks, but when you pull out a black one, I'm a really bad drawer. When you pull out a black sock, what you have left for the second time, so look at drawing a black sock and keeping it changed the probability. So this is dependent probability. Dependent. All right. So, and it started off with being 2 blacks. And when we pulled out a black sock the second time, there was only 1 black. So the probability, if the instructions were find that probability, you could reduce that to 1/3, or you could do 2 over 6 times 1 over 5, and you would get 2/30, and then you could reduce it. 2 goes into 2 once, 2 goes into 30. So you have a 1/15 probability of in the dark random, and let's say all the socks are the exact same size, same texture, because that's what theoretical probability is. All the socks are the same size, the same texture, probably the same brand. So you can't tell the black from the white from the brown. All right, but this is an example of dependent because you kept it out. And now this probability impacts your options on the second event. All right. A bag contains, this time I'm not even drawing the diagram, 4 red marbles, 5 blue marbles. You randomly, so we know that there's a total of 9. And you randomly pick a marble and then pick a second marble. Well, since you're keeping one of the marbles, now we only have 8 marbles. Without reaching the marble, the first marble is red, so there's a possibility of 4 in the first drawing. The second marble is blue. Well, there's now only 8 marbles left, but all of the blues still are there. So now 4/9 times 5/8. Now remember, diagonally, you could cancel then, or you could wait to the end. We could multiply 4 times 5. We can multiply 9 times 8. And then each of those have a 4 in common. It's probably easiest because we know 4 goes into 4 once and 4 goes into 8 twice. So now we have 1 over 9 times 5 over 2. And now when we multiply, numerator with numerator, denominator with denominator, there's a 5/18 probability that the first time you pick a red marble and the second time you pick a blue marble. All right. And I would recommend having some fake coins, or you making sure you have those coins, or a diagram like this. There are 3 nickels, 5 dimes, 4 quarters in your pocket. Now, the interesting thing about this, it's very difficult to randomly pick out coins because quarters are much bigger than nickels and dimes are the smallest. So I think that this is kind of a poor example. But you randomly pick 3 coins and place them on the counter. So that means you're keeping each time. The first 2 coins, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a total of 12 coins in your pocket, but you're going to keep one. So the next time you're only going to have 11, and then you keep that one. So the next time you're only going to have 10. Okay. So it says the first 2 coins you're going to pick are dimes. So look at dimes, there's a total of 5. But when we pick a dime, that means now there's only a total of 4. So now look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, a total of 10 coins. And then finally, the third one is a quarter. Well, we still have all 4 of those quarters. So if it says, if this is finding the probability, it is. So we have 5 over 12 times 4 over 11, and 4 over 10 each have a 2 in common. And then look at diagonally. You can even show kids that, because the other way to do it is say, well, this might be a better way to do it. Since it's multiplication, it doesn't matter the order. Ooh, those cancel. And then this 2 and this 12 share a 2. So that's going to cancel to 1. That's going to cancel to 6. Now look at what we have. We have 1 over 6 times 1 over 1 times 4 over 11. We could even go further, because look at this, 4 over 11 have a 2 in common. So 4 divided by 2 is 2. 6 divided by 2 is 3. So we have 1/3. When you multiply straight across. So there's a 2 in 33, 2/33 of a chance that if you're picking randomly, that the first 2 times you pick a dime and the third time you pick a quarter. All right. Factorials are what's called the fundamental counting principle. Now, what I recommend is you actually put on your desk 10 books, and preferably of different sizes. Maybe a thesaurus, or maybe a comic book. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? And you ask your students, how many different ways could you arrange those books? And maybe let's just give them all different letters. A, B, C, D, E, F, G, H, I, J. All right? All the different ways that those could be arranged. And actually have kids start to, I would spend a few minutes on this. And then show them, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? There's 10 slots, right? And maybe so what this means is, in this first slot, you have 10 options. In that first spot that you pick, you have 10 books to choose from. But then when you choose that, well, now we only have 9 books to choose from. And this is the fundamental. Then when you multiply all of that and have them multiply that out. So this is called, or one way to represent this is called a factorial. And that means you take the number that's listed and then you multiply it by all of the lower numbers down to 1, not 0, because if you multiplied it by 0, then the answer would be 0. So for this evaluate 5 factorial, make sure you're saying 5 factorial. 5 times 4 times 3 times 2 times 1. And you could have them do this. Oops. I left off the 100. Or however you would like them to do that. And I think that's it. And then, so the first couple days, when they're getting used to this, could be a pretty interactive activity, especially if you actually get a bag and you could just get pieces of paper all the same size with students' names on that. Or maybe with names of sports or something, and let them kind of interactively learn probability or sample spaces. All right, that's it.